Hello, welcome to Scimetschem. I am Raity Chandra. Today, I am going to start a new course on general organic chemistry. So, I am going to take an introduction class of this course. So, let me start. At first, the question that arises in our mind, that is, what is organic chemistry? Organic chemistry is nothing but the study of compounds that contain carbon. Why carbon? Why not over 100 elements that present in a periodic table? The reason is the electronic configuration of carbon. The electronic configuration of carbon is 1s2, 2s2, 2p2. That means there is 4 electrons in the outermost shell of the carbon. The formation of chemical compounds generally follows the octet rule. Which rule? Octet rule, which states that atoms always want 8 electrons in its outermost shell. By gaining or losing electrons to achieve optimum number of 8 electrons in the outermost shell. To this end, they can form ionic or covalent bonds. Let me take an example, that is sodium, and the electronic configuration is 1s2, 2s2, 2p6, 3s1. That means there is 1 electron in the outermost shell. To achieve 8 electrons in the outermost shell, sodium has 2 ways. It has to take 7 electrons to someone else, or have to take 7 electrons from another element, or have to give 1 electron to another. So the easiest way is to give this electron to someone else. And now sodium is Na plus and having electronic configuration 1s2, 2s2, 2p6, having 8 electrons in its outermost shell and obey octet rule. Octet rule. Let me take one more example, that is chlorine, having electronic configuration 2, 8, 7. There is 7 electron in its outermost shell, and the easiest way to achieve 8 electrons in its outermost shell, it take 1 electron from another element. So with both of this, NaCl ionic compound will be formed. So our concern is, why carbon? Because of its electronic configuration 1s2, 2s2, 2p2, carbon has 4 electrons in its outermost shell, and it is special because it is equally capable of donating and accepting 4 electrons. If it accepts 4 electrons from another element, it gains 8 electrons in its outermost shell and obeys octet rule. And if it gives this 4 electron to someone else, it also obeys octet rule. Another reason is that it can make bonds with itself, like C single bond C, C double bond C, and C triple bond C. And these bonds are very much strong. It is the special reason behind scientists choose carbon over any other element. Now the very important question is that, why not silicon? Silicon is the element just under carbon in a periodic table, just under carbon. And it is about 135 times abundant on Earth. It is also have 4 electrons in its outermost shell. Then why not organic chemistry based on silicon? The main reason is that carbon forms stronger bonds than silicon at temperature conductive to life. The 4 unpaired electrons in silicon are in third orbital, which can accommodate 18 electrons. doesn't follow octet rule. But in case of carbon, it is in second orbital and can accommodate 8 electrons and follows octet rule. As carbon-carbon is stronger than silicon-silicon bond, does carbon compounds stay together in water while silicon compounds break apart? Why? In the case of carbon-carbon bond, size of the carbon atoms are small. Thus, the overlap is strong. But in case of silicon-silicon bond, the silicon-silicon overlap is bad because of its size. That is why scientists choose carbon over silicon. Now, the very important question in this course is, why should we study GOC? Why should we study general organic chemistry? Because it plays a vital role to understand advanced organic chemistry like reaction mechanism, named reaction. Now, let me take this example. Okay. Take one ammonium molecule and one CH3I. Predict this product. How? How to approach a reaction? Organic chemistry is nothing but to give electron and to gain electron. Now, which one give and which one gain? To know this, we have to understand the nucleophile and electrophile concept very clearly. Which one is nucleophile and which one is electrophile? Think about this reaction. If we consider this product, that means NH3 act as nucleophile and CH3I act as electrophile. Now, this lone pair of electron is going to the sigma star of the some bond and some sigma bond is break. In case of this, we guess that the lone pair of electron is going to the sigma star of Ci bond and the Ci bond is break. And the product is that. Here, CN bond is formed and Ci bond break. In case of this product, here the product is NH3 plus CH3I. Here again CN bond form and CH bond break. Now which bond break? Which is more feasible? Which is more stable? To know this, we have to study type of bond cleavage, stability of the bonds. We have to know donor ability, acceptor ability of orbital. So in this course of organic chemistry, we are going to learn one by one concept of topics to make our organic chemistry stronger. With proper understanding of concept, we also have to prepare how to approach organic problems, because all we have to do is crack our exam. This is very, very important. So today I am going to talk about our course structure of GOC. The topic that we covered are: first, types of covalent bonds. Hybridization, very much important concept in organic chemistry. With orbital picture of compounds. Bond dissociation energy, bond order, bond length and their relationship. Fourth one, fission of covalent bonds. Fission of bonds. Then one by one, the effects: inductive effect, electromagnetic effect, then the base of organ chemistry, that is resonance, hyperconjugation. And then the concept of nucleophile, electrophiles, then acidity and basicity, next one minute, heat of hydrogenation, heat of combustion, decarboxylation, and their conditions. It's a very important topic for JEE Mains. SIR effect, SIP effect, proton sponge. Then carbocation and their stability, carbanion, their stability too. Then carbon radical, then dipole moment. It is also a very important topic for JEE Mains. Aromaticity, and last tautomerism. So it is the course structure, 18 topics that we are covered. So keep watching this channel. Thank you so much.